Everyone, welcome to my talk. I'm Edwin, and this is Terminal Velocity, how backend game services power our titles at Mediatonic. Let's get started, shall we? Apologies for the slight delay. So who am I? I'm Edwin Jones, the guy in the picture. I'm very hot. I don't know how you're dealing with the heat, but I am literally melting, and jeans were the wrong choice. I have a Twitter handle, I have a website, and all that jazz, but you're probably wondering why the heck I'm here. And what have I done? So I've been in game dev for quite a while. I started out with QA on Harry Potter back in sort of 2004 time, sort of EA Brightlight, that way. I was actually on TV for a bit doing Game Guru with Guru Larry. If anyone follows him on YouTube now, he's far more famous than I am. I have been an SET for Need for Speed and Battlefield and quite a few Criterion titles, but I've been a server engineer for Mediatonic for quite a while. So I have been there since 2017, and I like it. I find it really good. But obviously, we've had quite a few changes, which is hopefully why some of you are here to learn about where we've been, where we've come, and where we're going. So what do I do? Why am I talking to you? What's this talk about? So I create back-end services with a wider team to support our titles. So I am not the person who does everything. I have a huge team. I'm one of many. I'm just the one that's come to speak to you today. So you're probably asking, what the heck are back-end services? What do you use? How do you use them? And how the heck does it work on Fall Guys when I play the game and I'm matchmaking what's actually going on in the background? So back-end services, simply put, are just systems to support gameplay. They're self-contained applications. So if you're familiar with microservices, that's exactly what we do. So they do one thing and one thing only, but you deploy lots of them in a sort of a fleet, and that comes together to perform sort of all the back-end mesh that a game would need. And I like to think of them as the glue that holds the wider game together. So it's not actually like the game server you're playing on with 60 other people. It's more like your profile storage. When you equip a faceplate in Fall Guys, that gets saved to a profile store. That service that is running, that sort of handles those requests and handles the storage, makes that transactional, is a backend service. So it does player inventory, your purchase management, making sure that when you play on platform A and you move it to platform B, you've still got the same inventory, the same account. That's a service. Matchmaking itself, that's the front end of that is a game service. We use a different matchmaking system. We actually use the Fortnite matchmaker. But all the messages you send from the game client that come to us, they get filtered, you get batched together, and you get put onto that queue. That's all us. And sort of your login authentication, when you do the handshake with the external platform, like you're logging in via Epic on Switch, Xbox, PS4, our services are the things that validate your tokens, check you're all gravy, and let you in and give you access to your stuff. So that's what a backend service is. But how do we manage them? I've explained what they do, but what actually are they? So they're written in .NET, modern C#, in fact. And one of the reasons historically is because our client is a Unity code base, and so is our game service. It just makes things a lot easier for comms if everyone speaks the same lingo, and it also means it's easier to switch teams and things. And when you have discussions, everyone's on the same page. Obviously, as we're an Epic company now, that might surprise some people, but we've been using Unity for a long time, and it's worked very well for us. It's worked on previous titles like Gears Pop, if anyone's played that. And before that, our mobile titles such as Yahtzee with Buddies and things when we were doing Scopely games. Very long time ago now. They're platform agnostic, so we can host them anywhere. We generally actually stick them in Docker containers and throw them up on Kubernetes. I will skim over Docker and Kubernetes for now. I'm assuming a lot of you know of it. Some of you might not, but I'll jump some details as we go on, as we need to. They're highly available and they're bidirectional. So it's not like a REST API. It's more like sort of WebSockets and two-way comms. I'll go into the actual nitty-gritty in a bit. But the important thing is we can send messages to clients can send messages to us, and services can send messages between each other, which is like a core part of how our system works. We unit test everything, and we do more than unit testing. We do full-on end-to-end testing. We do integration testing. We have tests at every stage in our CI and CD pipelines. And importantly, they're scalable. Well, we aim them to be scalable. They're not always scalable, but they get there in the end, as we'll go on into the talk. How did this work on Fall Guys? Well, some of you will know the answer to this question, some of you won't, so let's go into it. It went pretty well. I mean, we're doing pretty well. We have lots of users. We're quite a popular title. I'm assuming some of you are here because you've heard about the game. So it's obviously something went right, but some of you may have noticed there were a few bumps in the road. So I'll explain the story. So our launch originally was in 2020, and that was sort of peak lockdown. We were coming out as a PS Plus title. We weren't expecting the world. This was our first big console game. It was the first time we were taking our backend services to such a scale, and we thought, oh, what's a good number? Oh, 80K. If we hit 80K, that's amazing. Like we are set. This project is funded. We can just roll with it. We also expected to launch during working hours, because why wouldn't you? Working hours being UK time, and we all work on the services side, so we're used to UTC for everything. Just worked really well. And we thought we could handle 2x the predicted load. So if we're expecting 80K, we'll scale to 160K. That's a nice safe window, right? You know, we're not going to do better than that. Unfortunately, we kind of broke everything. So we hit 650 CCU in the first week. So that's one day. So that's exponentially higher than we were expecting and even stress tested. We accidentally went live overnight on PS Plus while everybody was asleep. So that wasn't great. So everyone got pinged, and it also meant people were bleary-eyed and rolling on. And we were a very small team of sort of like 8 people at the time, and even fewer on Fall Guys itself, because we had, as I mentioned, Gears Up and other titles running at that time. So that wasn't great. And yeah, this was a lot more than 2x the sort of predicted load. And what broke? How did it break? I mean, I'm talking about load, but you probably want to know exactly what fell over. So before I get into that, I want to explain more about how systems work. So we use actor-based systems, and the best way to think of an actor is sort of an encapsulation of state that can send and receive messages. It's just an abstraction, sort of like Monad. Sounds complicated, but isn't really. The reason we like that is because it's really good for dealing with stuff like if you want to have a lot of concurrency, but you don't want to deal with threading in your logic, you can just have an actor for each instance of a thing, and that actor can send and receive messages about that thing and deal with them. For instance, the profile state I mentioned before, we spin up an actor per user. So when a user is saying, get me my inventory, that's going to one actor. Everything is happening in line, and they're getting responses back. There's no sort of no multi-threading, if you will. But as we have millions and millions of players any given day, obviously we need scaling, and that's how we do it. We achieve concurrency by just spinning up more and more actors. And yeah, I've covered this already. And where do we host these all? So we host them in Azure. As I mentioned before, we use Kubernetes, we use AKS. We also use Cosmos DB as a backing store. So if anyone's familiar with document databases, it's very similar to Mongo and DynamoDB. In fact, it's closest to DynamoDB because it's generally designed to be a highly available sort of multi-region system, and you can scale as high as you want. You just got to pay the money. So it's a very good model for us because quite often we need very high scaling. How is it all interconnected? How does our service talk to each other? As I mentioned before, our services can talk to and from the client and towards each other. So we use NATS. So this is quite a popular Golang program. I actually have written down what it is because most people don't know. I didn't know. It stands for Neural Atomic Transport System. But basically, it's a fancy way of saying it's a pub sub queue. But you can use it as a two-way system. And what you do is you publish 2 topics, which are just strings, and you subscribe to topics, and any subscriber can read any message and also send messages back on the topics, which is how our actors work. We basically have a partitioning system that uses consistent hashing. So when a request comes in for a player's actor, we go through some logic and say, okay, this player, what's their, some details about them, hash that. Okay, that makes them player 512. Okay, what's that actually in a topic? Right, we have a topic string. And we publish to that, and all our hosts, so we have several hundred sort of Kubernetes nodes running our services. They are all trying to listen for certain partitions, and they see a message come in going, I know I own 1/5 of all players, so that player is for me, and I will process that, and I will open actor on my node. So you sort of have a VM that runs a sort of a Kubernetes node that runs the pods, that runs the containers, that runs the actors. Say that 5 times fast. So what's it look like when it's all put together? This is going to be a little technical. So it looks like this. So basically, as I said, we've got our services in the back end here. We have more than one kind of actor, by the way. Our GCC player actor is a good example. It's all interconnected with NATS. Here's your game client there. It's talking to the CDN, which is how you know what your costume looks like after you equipped it. We don't store the textures or anything like that. Your game client also talks to the game server directly. It just auths through us, through the login system, which doesn't have an actor on the back end. It's literally just a 3-tier app. You know, your front end, your logic, your database. But we do just give you sort of like a JWT and use that to author the main gateway, which then proxies all the actors for you. And we handle things like when you request a match. As I said, there's a match actor system, very similar to the player one, but we're not running one per player. We're obviously running one per 60 players on average. And same for your lobbies and things like that. And we hit an external API for allocating the game servers and spinning them up. And we're also, I said before, player storage is in Cosmos. And we're sort of tracing things out to a Kibana stack, which is really good for logs at our scale. And obviously, for actual sort of metrics tracing things, Datadog's good is what we use for dashboards. So sort of like Grafana. Anyway, moving on. Now I've given you a bit of context, what actually broke. So we hadn't implemented proper circuit breaking for external systems. So if I showed you this slide before, you can see there's quite a few crucial things. This, not so important. This, very important. If you can't allocate servers and you have like 500,000 players trying to play, you're having a bad time. So things went down, things broke. We weren't expecting our scale. Our external partners weren't expecting our scale so much, not so quickly anyway. And things sort of fell over, and we didn't have proper circuit breaking, so we didn't have exponential back off. And also when we had outages from our provider, which did happen more than once, we just kept hammering. We get hammering and hammering and hammering, and it's like, give us a server, and the server's down, so that just leads to massive back pressure. So that gives you an impression of the next problem, which is thundering herd. So one thing we did is we had everyone who was logged in the game would check for refreshes of events and data and things like that from our content system at the same time every day without jitter. Classic problem, one we'd solved many times before on different titles, but you're always blindsided by the things you think you've covered. So yeah, basically everyone came in at the same time every day, knocked over everything, and it just led to, again, massive back pressure. But we fixed this by adding some jitter in, basically. And also, interestingly enough, NATs did not scale with our designs. So one of the problems we had, as I mentioned before about the topics, we misconfigured the system without proper partitioning. So rather than having each partition look at a subset of topics, each partition was looking for every topic, and NATs just couldn't handle the huge amount of load. And one of the problems we had is we couldn't actually scale out horizontally because it was quite difficult with our design to have sort of a NATs host see the messages from another NATs host. So we just had to scale vertically and basically throw money and get a bigger VM that was running the NATs system. And also, here's a great one. We had head of line blocking for reward processing. So some of you may or may not have noticed, but you don't actually get your rewards instantly when you finish a round in Fall Guys. It takes a little while. Well, most of the time, we're talking seconds, but sometimes this can be minutes, even longer, sometimes hours. You will always get them, but we only promise sort of eventual consistency there. So this wasn't good because we, as I mentioned before, we had problems with people logging in and things like that. So there were issues with other systems and outages and things, and I'll get the actual details here. So yeah, here we go. When we were updating hosts for the player system, basically, it was taking too long, and people couldn't get rewards if the player storage wasn't available to store those rewards. And that meant that even though we had load tested and balanced everything else, like at the end of game, get people out, get people's messages onto a queue, get people's rewards, ready to go, there's no way to put them. So it just led to more and more and more back pressure, which was not good. And yeah, that's just a reminder of the diagram I was going to skip through. But in the end, after all these problems, we did get around them in the ways I said, and it worked out pretty well, I think. So we ended up with best multiplayer game, best family game at the Golden Joysticks, which we were not expecting. We were not expecting to be the most downloaded PSN game of all time. This record still holds. Apparently, we are actually in the Guinness Book of World Records, which I wasn't aware of, because I thought someone would have beaten us by now, but they have not. I'm sure someone will come and beat us soon enough. So the main thing I'm trying to get at here is our core design sort of worked. We had issues, but we could scale them. We had problems, but they fit into sort of classical patterns, and so the solutions were obvious. Like when we had Thundering Herd, how do you solve it? Implement some jitter. When you have sort of issues with external providers, exponential back off. But we had the systems in place to make those changes to make it work. There wasn't something fundamental about our structure that wouldn't work. So what happened next? Well, there was quite a few things. I was going to go into more detail on this sort of about like how cross progression works. I did season pass, we did squads. They're quite cool. But I think you're all aware something bigger happened recently, and it was this going free to play. Now this was the big one. We thought it was going to be big. We scaled up a little bit. So we'd prepped, we'd wanted to do it for a while, actually. So we'd done extensive load testing, 3 million CCU, that'll be fine. we scaled up in Azure, as I said. You can just throw money at Cosmos, buy more RUs. It's fine. More ingress and outgress, basically, for connections. We informed our partners of the expected load. We said, hey, heads up, this time we know what we're going to get. This time, prepare for this. But again, you can guess what happened. So we had 20 million players in the first 48 hours, which just blew everything out the water again. We were not expecting that. We've had 50 million as of time of writing for the month, which is just absolutely bonkers. I mean, obviously, it's not even been a full month yet, so we're all still recovering from the shock a little bit. And I'm sure the number's actually higher now. So what actually fell over this time? So we hit 1 million CCU on day one, which doesn't sound that bad because I just said we'd load tested for 3 million. But unfortunately, again, we had that external system, that game server provider. It couldn't scale fast enough. It was not expecting the load because we hadn't actually tested everything. So one of the things we hadn't done is our game server actually needs Windows to run because it's basically just a copy of the Unity code base with different setup. And that meant that we didn't really want to pay for that many, X million Windows VM licenses for the actual OS. So we thought, you know what, we'll just dry run it. We'll just test all our side. We'll check with the provider, everything okay? And they'll say yay or nay, and we'll go with them. They know their systems, it'll be fine. But the problem is everyone, what's the saying? No plan survives engagement with the enemy, does it? So, and it wasn't just that fell over. Our login systems, we had tested them, but they couldn't handle the load when the game server failed, because one of our core flows, if you fail matchmaking, you boot out back to the main screen, and the main screen does a login, reauths, rechecks your content, gets ready for the next flow. But as everyone's failing to matchmake, they're hitting these systems, and things that worked at 3 million CCU on the golden path did not work with 1 million CCU on the unhappy path, which was our bad. So the takeaway here is you can load test, you can stress test, but there's always going to be something you don't know that's going to come and hit you, because there'll be holes in your system that you literally cannot see until launch day because you're not getting natural real load. So there will be little things you've proxied, little things you've mocked that just aren't really giving you a full coverage, because if you're not mocking them and you are doing it, you're spending a heck of a lot of money for your load tests. So what do we fix? So we had to throttle login. This wasn't a choice we made lightly. Throttling login meant players couldn't play, and players would log in and they'd get an error message. But if they kept retrying, if they're persistent, they would eventually get in. So this was considered better than nothing, because otherwise no one would get in because of just too much back pressure. And as fast as we could spin up login hosts, they were just failing due to the amount of requests. We optimized our game server allocation system. So we worked really hard with our external partner. And they were really good. They were Johnny on the spot with the ammo. They were up really late. They were talking to our engineers. They were fixing things. And we figured out how to sort of batch things up and make things more efficient for both sides, because they gave us a view into their systems. And we scaled up all the things. When you've got a problem like this, one of the solutions is indeed throw money at it. As I said, with Cosmos, you can buy more RUs. With Kubernetes, you can buy hosts that are bigger. You can pay for these things. So that's what we had to do. Sometimes vertical scaling is the answer. And sometimes horizontal. So what did we learn? So we learned a few more things. So we learned that stateful sets in Kubernetes can lead to long deployment times of hundreds of pods. So just to go back a bit, for people who might not know what Kubernetes and Docker are, Docker deals with images, Docker images, and you can think of them, they aren't VMs, but you can think of them as VMs that handle one application. So they're a great way of wrapping up your app, sticking it somewhere, and then replicating it so you can scale horizontally. Kubernetes really, at its heart, is just a way to manage that across multiple servers for you. So it was originally a Google thing, it's now a cloud native formation thing, a cloud native foundation thing, and it's just a nice way to abstract your cloud services. So rather than buying something specific from AWS, like Elastic Compute or whatever like that, you will just, you'll build your systems in Docker, you'll dry run some stuff locally, and you just pop it up on a hosted Kubernetes service. Anyway, yes, but one of the deployment methods for Kubernetes is a stateful set, and that basically means that each instance has to be replaced before it's switched off, which means that you have to do things in series. And we use that for our player system because it guarantees consistent naming, and we needed that because remember I was talking about the partitioning system and how the players have a consistent hash. So we need to make sure that each system basically knew what partition it was responsible for. And it's we ended up scaling up so high. I said we scaled up all the things. We at the moment, I think we have about 400. I think it's 400 pods handling just the player service alone, and it ended up taking 30-40 minutes to replace everything. So what that led to was Long deployments led to back pressure, because I mentioned before, if it takes a long time for things to update, people aren't getting their rewards. Back pressure leads to delays, and delays lead to player suffering. Nobody likes to play in the game, finish, and say, "Where's my stuff? I just got a crown. Where is it? What the hell's going on?" And hitting player support hitting us, people generally being unhappy. What else did we learn? So another thing that went wrong was we didn't actually hit before is verbose logging. So I'm not talking about literally using log level verbose. I'm just talking about logs that fire every time when they shouldn't because they've got a bug in them, or perhaps that they're just noisy, like they're putting out more text than they would. We were ending up firing dozens of gigs of logs daily, and it was just completely blowing our memory budgets for attached storage for the service. So what we decided to do is we log less, basically, and just switch to a higher log level, and also enable more logging on a per problem case. So if there was an issue we were seeing, then we'd switch log level down, but either just for a user or just for a host that was managing users that were seeing the problem, rather than just always keep this log on in production. And obviously another thing was logs that were saying things were wrong when they weren't were actually a lot more costly than we thought. We thought more logging is better, more traceability is better, but engineer time is one of the most valuable things you've got, right? And if engineers are jumping down rabbit holes when they're actually pressing problems, trying to solve problems that aren't real, then that's just costing time, and time is of the essence. But it's all working out pretty well again, because we're doing pretty well. So we were, as of writing of this tweet, which was in late July, we were the second biggest game on Xbox in the US, which kind of shocked me because I'm seeing, the immortal Grand Theft Auto 5, the game that shall not die. It's just doesn't follow the rules of nature. Call of Duty, that's pretty massive, and what we behind basically our sister product, Fortnite, which is just, I never thought we'd be on par with something that large. Because again, remember our original estimates were for about 80K. So that's bonkers. We're also the biggest free-to-play title, according to the PlayStation blog anyway, that they've got on all their platforms, which sort of blew my mind. I kind of thought there's no way you can beat Fortnite. Oh, wait, what? And PlayStation is one of our bigger platforms, so that is actually a significant chunk of the player base. Twitch, we beat Just Chatting. How the hell did we do that? I mean, no one beats Just Chatting. I mean, even League of Legends, Valorant, they can't beat Just Chatting. So I don't know how the heck we did this. Again, it's probably luck. But the point is we did pretty well. So despite the problems we had, we solved things quickly, we kept people engaged and people happy. And that's the main thing, right? So you make a game, you want people to enjoy what you work on. But that leads to sort of where we're going next. So we're going to continue to scale. Obviously, we're seeing more and more players. I'm not the business analyst. I can't tell you the growth curve or anything like that. But from what I've seen in meetings, it looks pretty healthy. We're going to add more features. Unfortunately, I can't go into detail because that would be crossing into sort of, company secrets and things I can't go into. But we're going to build more tech to solve the problems I mentioned about things, can avoid the problems we've had, like how do we deal with outages on providers, maybe bring more things in-house. How do we deal with scalability issues when you're dealing with something that needs to use that sort of update strategy I mentioned before on Kubernetes, things like that. So we're going to keep working. There's lots and lots to do, but you should generally see improvements in terms of how quickly you get your rewards and how quickly you get into matches as you go on. And that's leading me towards the end of this talk. So what I'm going to is sort of summarize on a few key points. So the main things I want us to would like you to take away is that Act systems provide a good model for concurrency. They're not the model for everything. They don't solve every problem. But if you're dealing with millions and millions of players, you probably don't want to be debugging threading issues as well as contention issues, as well as external partner issues. You'd probably like to not have that problem. And an Act system, assuming it fits your problem, is a good way to solve that. Scaling is always hard, but Kubernetes gives you options, as I said. It lets us sort of decide how we want to do things. Obviously, the strategy we're using now doesn't work for one service, but it works completely fine for others. And it also means there's no downtime because it's bringing something up before it brings something else down, so people don't really notice. As I mentioned before, load testing is critical, but you're not going to get everything. So do it, but don't expect it to be like a magic wand that makes all your problems go away at launch. Someone's going to be on call, and you need to be prepped for that. And maybe expect to launch overnight and have someone on call in the middle of the night rather than go to bed the night before a big launch, as we did. And there's going to be pain if you're launching a game and you're expecting even reasonable success, as we all are, right? We all make games. We all want them to do well. something will go wrong, but you can make your life easier by, the things we've done with the load testing, with the unit testing, with the, testing things on Kubernetes and stuff, meant that we had tools to solve these problems. And we solved these problems pretty quickly. Some of these things you would have probably noticed if you were an active player, but some of them you haven't, I hope. We'll see. And to follow on from this, because some of you, as I said, some of you will be familiar with Kubernetes, Docker, and all that. Some of you won't. I'll give you some materials. So if you want to know what Kubernetes, Docker, and containers are, I highly recommend a chap called Jeff Gerling. If you're into Raspberry Pi, he's pretty big in that community as well. If you read Hacker News, you've probably read his post and not realized it. The guy is lovely. His guide is completely free on YouTube. It's actually really good because a lot of Docker Kubernetes stuff is paywalled and gated, which just makes it a bit of a pain, I think, because not all of us have got the budgets to give our team access to this really crucial thing. So I love free resources. So I did actually skip over this because this was the original part of the slide, but our player system stores your inventory state with a thing called event sourcing, which is basically summing a series of events and changes into an aggregate and loading the aggregate state. And that's basically how our act system works, because actors can die, bring brought back. One of their core powers is their transient. And if you want to know more about event sourcing, the system we use, rather than sort of go into it for an hour now, I'd recommend this free post on GitHub, because it's a really good summary of how it works. And the act pattern itself, because I have glossed over a lot about how actors work. There's a lot more to them than I've said. I've just mentioned how we use them and the key benefits. I'd recommend this blog post because I find it really useful, because when I was coming up to speed, these are sort of the things that I kept bookmarked, and I thought would be handy for anyone else who'd be interested in learning this stuff. So with that, I just want to say thank you. Thank you all very much. Thank you so much for coming to my talk. It's been lovely to speak to you. I think we have a bit more time than I thought. Yeah, we have about 15 minutes. So I think we can probably open up for Q&A. So I will, that man there, I'm not sure who went first, so I'll let the mic shall decide. And also, I can't really see because there's a really bright light, so my apologies.
Hey, I'm the lucky one. Hi there. Really fascinating insights into the back-end stuff there. Really cool. I just wanted, looking ahead for future technologies that you're going to be developing and whatnot, have you considered things like distributed database technology and elliptic curve encryption for player authentication and reward delivery?
So we don't use anything super complicated for encryption. So as I mentioned before, we use JWTs. So they are cryptographically signed, but the claims are public. But it's public-private key encryption on the signature. So that means that when a user presents us, hey, I am Joe Bloggins and I am playing on PlayStation and my account is X years old, we know we can validate the signature and know that another one of our servers signed that. So we use very basic tools. But the thing is, sometimes there's nothing wrong. Don't reinvent the wheel if you don't need to. JWTs are tried and tested tech. We probably will need to deal with different things for different systems, like if we bring more matchmaking in-house or if we build new features and things. JWTs aren't going to scale for everything, but that's basically what we use for that. And I think you mentioned distributed databases. That's sort of what Cosmos is. Cosmos and Dynamo give you that for free. So that's sort of what we use, rather than having a sort of bespoke solution that we spin up ourselves.
I guess when I'm talking about distributed database technology, I'm hinting at blockchain.
Oh, no. So we don't need, the thing is, we don't need that at the moment. So in future titles, I don't know what the tech direction will be. Obviously, Fall Guys has shipped. Our tech stack's quite mature for this project. I'm sure there are smarter people than me at the company investigating if that's the best solution to some of our problems. I mean, it feels like it could be from the little I know about that sort of thing. But at the moment, I don't think that's something Fall Guys is going to do.
Great, thanks.
Cool. Next question. I think there's that side, and I'll move to that side of the room.
Thank you. Yes, I've just got two questions. I appreciate you might not be able to answer them for obvious reasons, but firstly, what kind of marketing went into those figures, those guesstimates as to how many likely players you were going to have? And secondly, even just anecdotally, what do you think it was that made the crowd go for this particular game? What was the reason behind the kind of?
Okay, for the numbers, I think, again, I'm not part of that team, but I can guess. And I believe what we were doing is looking at peer titles and basically going like, okay, previous titles we've had, I said Gears Pop, peer titles, what's the average? Average some stuff out, spitball, get some best guesses, and then double them. As I said, we doubled our initial estimates, but that wasn't enough. What was the second question again? Sorry, there was two.
I'm just interested in your opinion as to why this game did so successfully.
All right. Well, I think a huge part of it is luck. I mean, we all make good games, right? No one makes something they don't want to make. But I think there were several things that worked in our favor. One, PS Plus, that was massive. Our game was free. It was effectively free to play before it was free to play. And PlayStation at the time was our far biggest market. You know, we were just PlayStation Steam for quite a while, and console is a huge install base. There's no getting around that. And also, we can't really forget the sad fact that we're all locked in our own houses in 2020, mostly. So I think a lot of people just wanted an escape, and they didn't want shooty, shooty, bang, bang. They didn't want Murder Your Friends, the video game. They wanted something chill. They also wanted something they can play with their kids. Maybe they were kids. I don't have demographics to hand. I know we have quite a wide demographic, and we skew younger than other competing titles. So I think it really was just the perfect storm, really. And that kicked us off the first time round. As the second time round, obviously free to play. I think if you've got a game like this and you've got the money to support yourself building up to free to play, it's something you should investigate, because I didn't think it would have the effect that it did, but I was told that it would. And I was like, all right, we'll see. Okay. Wow. Okay. That really is, free to play really does give a game a kick up the arse if you're in certain markets. And we are it's lots of people playing together. It's 60 people in a game. Sort of that's our target. So that is streamers playing it, saying, come on, play my game with me. I mean, I don't know half the names of these people, but we had Mr. Beast playing, and Tim the Tatman. Again, I'm a bit old for all this, but very big streamers. I'm been told with fan bases in the thousands. So if they're playing and they tell their fans, come play with me, that gets people picking up the game. And if it's free to play and you can install it on anything and you can do the cross progression, so you're playing on PlayStation, someone comes in, you hand the control to them, jump on Switch, playing together, I think that's got real power. So I think the main thing free to play gives you is it drops the barriers. It doesn't solve all the problems. Obviously, you need a monetization system, but it does mean people have fewer reasons not to play your title over another. I mean, it's worth other people, right? It worked so well for Apex a few years ago. Obviously, Fortnite's done very well on it. But I won't pretend it solves all things. I think it's for us at the moment, it's what's driving a lot of our growth. Cool. And I think someone on this side now. There's a man there in a mask, I think. Are we handing out the mic fairly? I want to make sure everyone's getting a good chance. Is anyone waiting ahead of this man? Cool. Okay.
Yeah, thanks for the talk. So I have one tech question. How do your microservices talk to each other? And do you use the message broker? And would you recommend using message broker in those scenarios?
So I did have a slide on this earlier. So this was NATS. So that's how our systems talk to each other. So NATS is basically a pub sub layer that lives inside each cluster. So every service can see NATS. And we're talking basically by sending protobuf messages. We don't use JSON or anything. So we're just encapsulating messages in a protobuf serialization format, mostly binary, jamming that onto a topic that anyone can subscribe to. But because of our partitioning system, the hosts that care can subscribe to. And they're basically listening out for the things on those topics, sending those messages, and then processing them and sending responses. So it's part of the handshake. When it first receives the messages, you create a reply topic and go on that. So it's not the same thing as you're talking about, but that's what we use. And I don't know if it's the best thing ever, but it more than works for us. Our initial scaling issues were due to misconfiguration. As I said, we had every partition listening for every message, which is not what our partitioning system should do. It should handle a section of your requests or your throughput, not all of it. So that wasn't Nat's fault. That was us. And I think it's obviously as it's Go, it's really handy. I'm a big fan of Golang myself. I don't get to use it very much professionally. As I said, we're a .NET shop, but there is something to be said for just being able to have a memory managed language that compiles down to native, gives you a little binary, stick it where you want, and that's it. There's no npm install step. There's no deterministic install step. It's like, no, here's your binary. And if you're sticking to like one OS for your host, it just needs to be one platform's binary, and off you go. Makes life easier. Now, obviously, there's differences. You wouldn't use Go for like a graphical application or anything, but for game services, nothing we do is graphical. It's all back-end. It's all data orientated. So yeah, I would heavily recommend looking at it if you haven't considered it, but we don't use anything else at the moment.
Thank you very much.
You're welcome. Who's next? Anyone else? Any other questions? Cool. I will give you your time back then. Thank you very much for coming, and thank you for listening.